So today we are solving trig equations with identities. So we've already solved trig equations. We did that before we actually looked at identities, but all we had to do there was factor and then just straight up solve. So since we've looked at identities, we need to, on these, we're going to have to apply the identities to be able to get to the point where we can actually solve them. On number 1, there's a correction that you need to make. Where the interval goes from negative infinity to infinity, we're going to change that to 0 to 2 pi. There's also one on your assignment that you'll have to change like that. My intention is to tell you that when I hand it to you, but if I completely forget and you get to one that has negative infinity to infinity, change it to 0 to 2 pi. It's not that it's wrong, we're just not going to go down that road. Okay, I don't think it's necessary. All right, so let's look at what we've got here. So I've got cosine of x minus 1 equals sine squared x. So if I want to solve that or factor it in some way, I'm going to have to do something to it because as it is, there's nothing I can do. But I do know if I'm looking for identity stuff that if I have a squared, I want to look at my Pythagorean identities, right? And so since I have my Pythagorean identity, I have one that says sine squared plus cosine squared equals 1. Then I can substitute this sine squared with something that has cosine squared in it. So I'm going to rewrite the left-hand side. Cosine of x minus 1 equals, and then what can I substitute for sine squared? Good. 1 minus cosine squared. Okay. All right, so now I have a quadratic, and in order to factor a quadratic or to factor anything, I want to set it equal to 0. So I'm going to move everything to the left so my squared term stays positive. So I get a cosine squared x plus cosine x minus 2 equals 0. Okay. Then I have something that I can factor, right? Cosine x, and then what are my numbers? Close. Positive 2 and negative 1. Okay. So then I'm going to solve this. So this will give me cosine x equals negative 2, and my interval is 0 to 2 pi, so I'm using the whole circle. So when does cosine give me negative 2? Never, right? It doesn't, because it can't be less than negative 1. And then I get cosine x equals 1. So between 0 and 2 pi, when does cosine give me 1? 0 and 2 pi. That's my answer then. What questions do you have? We good? All right. So on number 2, I've got this cotangent squared and cosecant. Are cotangent and cosecant related with the Pythagorean identities? Yes, they are. So what can I replace cotangent squared with? Cosecant squared minus 1. So I can have cosecant squared theta minus 1 minus 3 cosecant theta plus 3 equals 0. Right. So then that gives me cosecant squared theta minus 3 cosecant theta plus 2 equals 0. Then I can factor this. This will give me cosecant theta and cosecant theta. And then what are my two numbers? Negative 2 and negative 1. And I'm going from 0 to 2 pi again, so I'm using the whole circle here. So this will give me cosecant theta equals 2, and cosecant theta equals 1. But I don't want to deal with cosecant once I get it solved like this. What's the reciprocal of cosecant? Sine. So I'm going to get the sine of 1 equals 1/2. I'm sorry, equals 1/2. And sine equals 1. Okay. Hang on. I just cannot write this correctly. So sine theta is what I'm trying to write, equals 1/2. And sine theta equals 1. Okay. So sine is positive in the first and second quadrants. So when does sine give me 1/2? Pi 6 and 5 pi 6. Yes, good. All right. And then when is sine 1? Pi halves. Good. So that means altogether my answer is pi 6, pi halves, and 5 pi 6. Okay. What questions do you have? Anything? Good? Okay. All right, so let's look at number 3. So number 3, I don't have any Pythagorean anything, but I know that tangent is a quotient function, so I could make it sine over cosine, and I have a sine there, so I think I'm going to try that. So we'll make this 3 times sine alpha over cosine alpha minus 2 square roots of 3 times sine alpha equals 0. All right, so now I have 2 terms that are combined and set equal to 0. Is there a GCF that I can factor out? Sine. I can factor out the sine of alpha. Multiply that times 3 times 1 over cosine alpha minus 2 square roots of 3, and that equals 0. So what's 1 over cosine? Secant. So I think I want to make this sine alpha times 3 secant alpha minus 2 square root of 3 equals 0. So I have this factored as much as it can be factored. Solve this, and on this one I'm going from pi to 2 pi. So I've got sine of alpha equals 0. So between pi and 2 pi, when does sine equal 0? Pi and 2 pi. Okay, and then this gives me 3 secant alpha equals 2 square roots of 3. So that means that secant alpha is equal to 2 square root of 3 over 3. So now that I have it solved, I don't want to have to think about secant alpha anymore. I want to make that cosine alpha. And what's the reciprocal of 2 square root of 3 over 3? Square root of 3 over 2. Very good. So then cosine is positive in the 4th quadrant. Square root of 3 over 2 gives me a pi 6th angle. So my 4th quadrant pi 6th angle is 11 pi 6. Which means overall, my answer is pi 11 pi 6 and 2 pi. What questions do you have? You good? Okie dokie. So let's look at number 4. So number 4, I could try and do the same kind of thing I just did, because secant's 1 over cosine. This would be sine over cosine, which means I would have something to factor out, but I don't get to factor until I've set it equal to 0. And once I move that 1 over there, then I don't have a a GCF anymore, and it kind of messes things up. So we can try and do a few different things, but we're going to have to do something a little outside the box on this. If you look at your Pythagorean identities, you'll see that tangent and secant are related in one of them. Our problem here is that it's not squared, so we can't just substitute it in like that. But that doesn't mean we can't get it into that form. So I'm going to move this tangent over, so I get tangent plus 1 over there. So this will give me secant of x equals tangent x plus 1. So, you know, the general idea of solving is that whatever you do to one side, you have to do to the other. And as long as you keep your equation balanced, most stuff is going to be legal. So if I would like to make this secant squared so that I could get a tangent squared out of it, I can square it, but if I square this side, I have to square this side, okay? Which is totally legal. We can square both sides and go from there. But I'm going to put a little star right here because since we do that, there's an extra step at the end, okay? And we'll talk about what that is once we get there. So when I square this, on the left, this gives me secant squared x equals. This does not give me tangent squared x plus 1, or I go to math jail, okay? You're going to get a trinomial out of that. If you have to go off to the side and FOIL it out, that's fine. But what you get is tangent squared x plus 2 tangent x plus 1. So now that I have that, I have to decide if I want it in terms of secant or in terms of tangent. But I think since I have all this tangent stuff over here, I definitely want it in terms of tangent. So when I look at my reference chart, what do I replace secant squared with? Tangent squared plus 1. So this is going to be tangent squared x plus 1 equals tangent squared x plus 2 tangent x plus 1. Right? So when I start to move everything over to one side, when I subtract tangent squared x from both sides, those zero out. When I subtract 1 from both sides, those zero out. So that leaves me with 0 equals 2 tangent x, right? Which means that 0 equals tangent x. And I'm going from 0 to 2 pi, so we're using the whole circle here. When is tangent 0? 0, pi, and what? 2 pi. All right, so remember that little asterisk I put up there? This is why. Okay, so just pause on that for a second. Totally separate idea, totally separate problem over here that I'm just making up. If I tell you that x is equal to negative 3, okay, just a statement, x equals negative 3, then we can square both sides like we just did. And when I do that, I will get x squared equals a positive 9. Do you agree with that? Okay. So then if I said, all right, you have x squared equals 9, solve that. So you take the square root of both sides, and you get that x equals plus or minus 3. But x didn't equal plus or minus 3. It just equaled negative 3, right? So because we squared it as a way to solve it, which was kind of unnecessary in this one, but still fine, we have to substitute back in and check for extraneous solutions. Because you could possibly have solutions that aren't real solutions. It's not always a guarantee. That's why you have to check. Okay? Because if I then took both of these and said, all right, I'm going to substitute the positive 3 up in here and say positive 3 equals negative 3. Oh, that one doesn't work. But negative 3 equals negative 3. Okay, so since we have these three answers here, we have to substitute them in and see what's going to work. So I substitute them back into the original. I'm going to take this 0. Okay, so I want the secant of 0, which means I really want the cosine of 0. What's the cosine of 0? 1. When the angle's 0, cosine is 1, right? The reciprocal of 1 is 1. Then I'm going to subtract from that the tangent of 0. What's the tangent of 0? 0. Does that equal 1? Yes, it does. That equals 1. That's a good answer. Okay? Just checking. Take the pi. The secant of pi. So what's the cosine of pi? Negative 1, and the reciprocal of negative 1 is negative 1. So negative 1 minus, what's the tangent of pi? 0. And does that equal 1? No, it does not. So this one doesn't work. Pi is an extraneous solution. Okay. 2 pi is in the exact same spot as 0, so the exact same things are going to happen, and that's going to work. So I had one extraneous solution. My answers are really only 0 and 2 pi. Okay. Everybody okay with that? So you don't have to check your answers every time. It's only if you decide to square both sides. Just like if you take the square root, you have to put a plus or minus. If you square both sides, then you have to check for extraneous solutions. Okay? We good? All right. Let's look at number 5. Any questions on anything before we move on? All right. So I have here sine of 2u plus 4 cosine u equals 3 cosine u. So I have a double angle identity right here that I know that there's something on here. So I find my double angles. They're right past the middle. And your sine of 2 theta is 2 sine theta cosine theta. So I'm just going to replace this with 2 sine u cosine u. And that's plus 4 cosine u equals 3 cosine u. Okay. If I want to be able to factor this, which I know I'm going to have to factor if I'm multiplying 2 different trig operations together, so I need to set it equal to 0, so I'm going to move this to the left here, and I will get 2 sine u cosine u plus cosine u equals 0. Then can I factor? Yes, I got a GCF. I can factor out the cosine u. That leaves me with 2 sine u plus 1 equals 0. So then, I can solve these. I'm going from 0 to 2 pi, so that's the whole circle. I have cosine u equals 0. So when does cosine equal 0? Pi halves and 3 pi halves. And then I get 2 sine u equals negative 1. So sine u equals negative 1/2. Sine is negative in the third and fourth quadrants. So what are my u values there? Good. 7 pi 6 and 11 pi 6. So when I get all that in the right order, I get pi halves, 7 pi 6, 3 pi halves, and 11 pi 6. What questions do you have? Anything? You can totally do this. You just got to knock some cobwebs off since it's been about a week, I'm sure, since you've even thought about this stuff. All right, so let's look at number 6. On number 6, I've got cotangent of 2 theta times times 2 tangent theta plus 2 equals 0. So when you look at your double angles, do you see a cotangent of 2 theta? No, I don't see one. I see sine, cosine, and tangent, right? But cotangent 2 theta, the reciprocal of that is tangent 2 theta. And since the tangent 2 theta identity is just one fraction, I can just take the reciprocal of that fraction. I could do that with sine of 2 theta also. I could not do that with the cosines, though, because they're all more than one term. Okay, but that tangent 2 theta is just one big ugly term. All I have to do is literally take the reciprocal, so that cotangent 2 theta would be 1 minus tangent squared theta over 2 tangent theta. Okay. So that's what I replaced this part with. Okay, now I'm just going to rewrite the rest. So I'm going to multiply that times 2 tangent theta. Then plus 2 equals 0. Is there anything I can cancel out right now? The 2 tangent thetas, yeah, because this is like over 1 right here, so that's just gone. So I get 1 minus tangent squared theta plus 2 equals 0. So 1 minus tangent squared plus 2 is going to give me 3 minus tangent squared equals 0, because that negative does not get distributed there. So that means that 3 equals tangent squared theta. So when I take the square root of both sides, I get plus or minus the square root of 3 equals tangent theta. I'm going this time from pi halves to 3 pi halves. I want this to be positive and negative, and I know that tangent will give me a square root of 3 at a pi thirds angle. So I need my second quadrant pi thirds angle, which is what? 2 pi thirds, and then my third quadrant, which is 4 pi thirds. Very good. Okay. What questions do we have? Anything at all? Good? Okie dokie. All right, so now we have sum and difference angle identity, or sum and difference identities. These look very similar to the cofunction identities, but notice all of the cofunction identities have pi halves minus theta. Every time it has to be pi halves. So that's not what this is. These are not cofunctions. But they are the sum and difference, sine of A plus B or sine of A minus B. Okay? So if I have this as, this would be sine of A minus B, this first one right here, right? So I'm going to find sine of A minus B. That becomes sine of A times cosine of B. So that means I'd get sine of pi sixths times cosine of beta minus cosine of pi sixths times sine of beta. Okay. Everybody understand where I'm getting that from? Right here, sum and difference identities. It's right above the middle part. You see it now? Okay. Just using that pattern there. Then this will be cosine of A minus B. That's what this part's going to be. But I have a minus in front of it, so I'm going to have minus, and I'm going to open my parentheses. Okay, because it's going to be more than one term. And then the A minus B, that makes it cosine A times cosine B. So I'd have cosine of pi thirds times cosine of beta plus sine of pi thirds sine beta. Close my parentheses and then finish that off. That equals square root of 6 over 2. Make sure you understand where all that came from and why. I didn't make it up. I didn't get it out of my brain. I got it off of the reference sheet. We're all good at this point? Okay. No? Okay, so there's a lot going on there. What I have here that I haven't had in some of the other ones is that I have things I can actually evaluate. They're not all variables. I know what the sine of pi 6 is. I know what the cosine of pi 6 is. So I'm going to go ahead and evaluate those things. So what is the sine of pi 6? 1/2. So I can make that right there 1/2 times the cosine of beta. Then I have minus cosine of pi 6. What's the cosine of pi 6? Square root of 3 over 2. So that's minus square root of 3 over 2 times the sine of beta. Minus, and I'm going to have to distribute this negative sign into here. What's the cosine of pi thirds? 1/2. So that's 1/2 cosine beta. Then since I'm distributing the negative, I also have a minus. What's the sine of pi thirds? Square root of 3 over 2 times the sine of beta. That's equal to the square root of 6 over 2. So make sure you understand where everything came from. Ask me a question if I lost you somewhere. Very good. You got a question? You figured it out? Okay. All right. So we're good? Okay. So now I'm going to start to combine things. I have this 1/2 cosine beta minus 1/2 cosine beta. Those are going to zero out. I have this negative square root of 3 over 2 sine beta and negative square root of 3 over 2 sine beta. Those do not zero out. I get 2 of them. So that gives me a negative 2 times the square root of 3 over 2. What does that end up being? It's just the square root of 3 because you have 2 of them. You have 2 halves, it gives you a whole. Well, yeah, it's negative. I just put it up front, but yes. But yes, it is negative. Okay. So I get negative square root of 3 times the sine of beta equals the square root of 6 over 2. So I need to divide by the square root of 3. So as not to make my life harder, remember that dividing by something is the same thing as multiplying by 1 over that thing. Dividing by 2 is the same as multiplying by 1/2. So dividing by a negative square root of 3 is the same as multiplying by 1 over negative square root of 3. So that means that sine beta is going to equal the square root of 6 over 2 times negative 1 over the square root of 3. Which will, when I multiply straight across, gives me negative square root of 6 over 2 square roots of 3. When you divide square roots, or things with square roots, you can divide everything outside the square root together and everything inside the square root together, which means 3 goes into 3 once, into 6 twice. And what I really have here is that the sine of beta is negative square root of 2 over 2. Then I got to figure out what so 0 to 2 pi, I'm using the whole circle here. Sine is negative in the third and fourth quadrants. Square root of 2 over 2 gives me a pi fourths angle, right? Yep, 5 pi fourths and 7 pi fourths. Oh, it's not that complicated. You just have to be able to keep up with your work. I wouldn't skip a bunch of steps if I were you. That's where you get into trouble, especially with the negatives. Paying attention to carrying those negatives, drawing the arrows if you need to, whatever you got to do so you don't mess that part up, because then it just throws off everything. Because most of the time here, it's not the trig that's the problem. It's the adding and subtracting and the square roots. What questions you got? We good? Alrighty. Then let's look at number 8. All right, so we have half-angle identities. So look on your chart, the half-angle identities are about 3/4 of the way down on the sheet. You have 1 for sine, 1 for cosine, 3 for tangent. That means with tangent, we have to make a decision. But luckily here, this is the sine of x over 2, so that's like sine of theta over 2. So I see what I can substitute in. So let me just rewrite the left-hand side here. Cosine of x plus 2 equals, and then the sine of theta over 2 is plus or minus big old square root 1 minus cosine theta over 2. So on the front, we had to think outside the box a little bit to know to square both sides. Here, it's kind of almost, that's really all you can do, right? If I got to get rid of a square root, the only thing I can do to get rid of a square root is to square both sides. So we are going to square both sides. So when I square this, I do not get cosine squared plus 4, or I go to math jail. Instead, I get cosine squared x plus 4 cosine x plus 4 equals, then on the right-hand side, when I square it, I just get what's underneath the square root. So I get 1 minus cosine theta over 2. I would like to get rid of the square root. So I can multiply both sides by 2. When I do that over here, these 2's just cancel out. But on the left-hand side, I have to multiply everything by 2. So 2 cosine squared x plus 8 cosine x plus 8 equals 1 minus cosine x. Oh, I ended up with a theta right there. Sorry, I was confusing myself. When I took it off the formula chart, I put a theta. It should be x. Okay. So now I've got a quadratic. I need to set it equal to 0, so I'm going to move everything over to the left. So I've got 2 cosine squared x plus 9 cosine x plus 7 equals 0. I added this one over here. All right, so I need to factor. A is not 1, so I'm going to factor by grouping. I do 2 times 7. That gives me 14. So I need two numbers that multiply to give me 14, combine to give me 9. What is that? 7 and 2. So 2 cosine squared x plus 7 cosine x plus 2 cosine x plus 7 equals 0. Then I'm jumping the gun there, sorry. So out of these first two, I'm going to factor out a cosine x. That leaves me with 2 cosine x plus 7. Out of these two, I can factor out a 1. That leaves me with 2 cosine x plus 7. All that equals 0. So I get 2 cosine x plus 7 times cosine x plus 1 equals 0. Solve this. Let's see. I've got, I forgot to put a little star up here. We squared both sides, so we're going to have to check for extraneous solutions, right? I'll star to remind myself. And I'm going from 0 to 2 pi, so I'm using the whole circle here. All right. So this gives me 2 cosine x equals negative 7. So cosine x equals negative 7 halves. When does cosine give me negative 7 halves? Never. That's right, never. So that one doesn't work. Then I get cosine x equals negative 1. When is cosine negative 1? Pi. Okay. So I only have one answer, but it still could be an extraneous solution, so I have to check it. So I'm going to go back up here to look at what I'm substituting into here. I'm going to substitute pi into here. What's the cosine of pi? Negative 1. So I'll have negative 1 plus 2 equals, and then sine of pi over 2, what's sine of pi over 2? 1. Is negative 1 plus 2 equal to 1? Yes, it is. So that means that this is my one and only answer here, and I'm done. Okay. Do you have to check for extraneous solutions every single time? No, only when? When you square it. Okay, very good. All right, let's look at number 9. So I've got half angles here. Let's see, I'm going to go ahead and write down this 1/2 here. It has nothing to do with the angle. 1/2 times, then I have tangent of a over 2. So when I look at my chart, look at it, you see that tangent has 3 choices, right? So if I'm not going to square it or do anything fancy, I would really like to avoid that first one if I could. Okay, so I think that one's out. Then of the other two, they're very, very similar, but if I have the choice and I can have one term in my denominator instead of 2, one term is always better in the denominator. So I think I'm going to pick that middle one. Okay? Unless, if there wasn't something that was just glaringly obvious of a reason you might want to pick another one, that's probably a good go-to one there. So this would be, I'm just going to substitute in 1 minus cosine A in the numerator over sine A. Okay. Then minus, so I've got cosine squared of the half angle. So that means I'm going to put in whatever that identity is and square it. So I'm going to open some parentheses, look at my cosine of theta over 2, and that is plus or minus the square root of 1 plus cosine A over 2. And then I still have to multiply that by cosecant, and that equals 1. Any questions about where anything came from or why? I put the parentheses to do it. I did not put the squared. Thank you very much. There you go. I meant to, but thank you. All right. Now do we all agree? Good catch. Thank you. All right. So in this first one, if I just extend this, I can multiply those together, and that's going to give me 1 minus cosine A over 2 sine A. Minus, now when I square this big old square root, I just get what's underneath it, right? So that'll give me 1 plus cosine A over 2 times, well, everything is in terms of sine and cosine except the cosecant. So I think I want to use the reciprocal. What's the reciprocal of cosecant? Sine. So this will be 1 over sine A, and that equals 1. So even though in that second term I haven't actually multiplied these yet, when I do multiply them, I'll have a denominator that's 2 times sine A, right? Which means these two fractions have a common denominator. My common denominator is 2 sine A. The numerator of the first one is 1 minus cosine A. Then I'm going to subtract. That second numerator has 2 terms, so I have to have parentheses there. And here's where you want to make sure you don't get sloppy and skip steps. And think, oh, I don't need to rewrite that. I can figure that out. You probably can, but you also might mess up on something simple like a sine. So when I'm here then, I've got 2 sine A in the denominator. So 1 minus 1, those zero out. But then I have a negative cosine A minus cosine A, which is going to give me a negative 2 cosine A in the numerator. And that equals 1. Can I cancel out those 2's? Yes, I can. So that leaves me with negative cosine A over sine A. And what's cosine over sine? Cotangent. So I get negative cotangent A equals 1, which means cotangent A equals negative 1, which means tangent A equals what? Negative 1. And we are going from, forgot to look, pi to 2 pi here. So from pi to 2 pi, tangent is negative just in the fourth quadrant. So what would your answer be? 7 pi fourths. What questions do you have? We good? Okay, so let me hand out your assignment so I don't forget to tell you what to fix. It's still fresh on my mind here. And tomorrow in class, this is what we're going to be working on, because it'll take you a little bit longer than some of your Delta Math assignments. I know that. I want you to be able to ask questions and whatnot. So it would still be a good idea to get started on it now, so that you can come in with some questions and don't just come in with it blank. But number 2 is the one where you want to change the interval from negative infinity to 0 to 2 pi. Okay, so just fix that and you'll be good.